Okay, hello bro. Back with me Rannegoro. We are going to discuss about some classical mechanics questions or problems at the undergraduate or postgraduate level. Problems that we will discuss is related to projectile motion or parabolic equation with some kinematics equation approach. Okay, prepare yourself to enter the world of classical mechanics. Okay, the first problem. At what angle should a ball be thrown so that its maximum height equals the horizontal distance traveled? Okay, let's solve this problem. Okay, we know from equation of vertical motion is Vt equals Voy minus Gto, and we can change this form with T, shift to left side, To, Voy minus Vt divided by G. Okay, we know from this problem that Vt in a vertical motion, in a top, Vt is equals 0. So we can remove this term and we get Voy divided by G, so that the times or the maximum times the ball in the air is 2, the max is 2 times To, because the time upward, this is a time to upward direction, it's same to the time downward. So maximum time or time a ball in the air is 2 times To, and To we can substitute by Voy divided by G, and we know that Voy is equal Vo sin theta. So this is the times that the ball in the air, and we know that equation of horizontal motion yields the horizontal distance. This is the vertical motion. Horizontal motion yields the horizontal distance x Vox times T maximum, and we can substitute Vox by Vo cos theta times T max, and we can substitute T max by this term Vo cos theta times 2 Vo sin theta divided by G, and we can calculate this term. We can multiply this term, we get 2 Vo square sin theta cos theta divided by G. Okay, this is the analysis of horizontal motion. Okay, the time to the top is 2 To Vo sin theta. Okay, so the maximum height is, okay, looking at the ball fall back down to the ground, and we know that the equation is Vt square equals Voy square minus 2gh, and at the top Vt is 0, so we substitute this term. Okay, Vo sin theta 2gh, and we get h equals Vo square sin square theta divided by 2 times G. We save it. Okay, and from Vfall we get equation like this: h Voy times T plus 1/2 Gt square, and from this equation we know that Voy at the top, this is a difference term, yes. Voy, okay, let's make it with the identity 2. From this equation we know that VOY2 is equal 0. This is the velocity at the top. So we get the h equals gt square divided by 2. Okay, we save it and we get two equation of h. Okay, this question is what angle that the maximum height equals the horizontal distance traveled. So we can write it as x equals h, that x is 2 times VO blah blah blah. We can write it again like this: 2 times VO sin theta cos theta divided by g equals h is VO. Okay, we write it in this side: VO square sin square theta divided by 2g. We can remove g and we get, okay, sin and VO square, and we get 2 cos theta sin theta divided by 2, and we get sin theta divided by cos theta equals 2 times 2 equals 4. And this time, by identity of trigonometry, we get that tan theta equals 4. So we get the angle of this condition is theta equals arcus tan 4. Calculated by the computer, we get that theta equals 276 degree. Okay, we get the angle of the condition like that. Okay, we move to the second question. A ball is dropped from rest at height h. At height y, it bounces off a surface with no loss in speed. The surface is inclined at 45 degree, so the ball bounces off horizontally. What should y be so that the ball travels the maximum horizontal distance? What is this maximum distance? Okay, let's solve this question. Okay, first we can illustrate this condition that a ball is dropped from rest, so VO is 0. Okay, that bounce like this horizontally. The incline is at 45 degree. Okay, like this. Okay, 45 degree and bounce at height of y. Okay, like this. So let v be the speed bounce, okay, which is the same as the speed right before the bounce. If ty is the time to hit the surface, then surface, okay, we can write equation from the kinematic equation. T1 is the time to hit the surface. This is the plus 1/2 gt square, and we can write s. This is okay, this is the h, so s is h minus y, and this is term is 0 because a ball is dropped from rest condition. So we get 1/2 gt square, and t1 equals 2 times h minus y divided by g. Okay, this is the times t1, and so v, the horizontal velocity, equals gt1 equals g 2 times hy divided by g, and we can simply this term by this g move to inside of the square root. Okay, and we get 2g times h minus y. Okay, this equation from the kinematic equation that VO or V initial velocity is 0, so we can analyze the V by term of gt. Okay, the vertical speed is 0 right after the bounce, so the time it takes to hit the ground is given. Okay, we analyze the times that the ball hit, so we can illustrate that V is parabolic, or we have the parabolic path that the height is y, and this distance is x, so we can write as x equals VOY t2. This is time to hit the ground, plus 1/2 gt square, and we get y as substitute by y, and this is 0. This is the vertical speed on this condition. VOY is 0, and we get y equals 1/2 gt2 square, and we can write gt2 equals square root of 2y divided by g. Okay, this is the time ball takes to hit the ground, so the horizontal distance traveled is therefore x, and velocity is v2 and times 2 t2. This is a constant velocity, so there is no acceleration of this equation, so we get v equals this term, 2 square root of 2g times h, 2g times h minus y, and t2 equals square root of 2y divided by g, and we can multiply this term to this term, and we get 4 h minus y times y, and we can simply this term by get outside this, okay, and it's changed like this. Okay, so we get maximum horizontal distance from this. Okay, from this question is x equals to square root of y times hy, like this. Okay, this is the term that the horizontal distance of this condition. And what is this maximum distance? We can taking the derivative, and we see that this function of y is maximum at y equals 2 divided by h divided by 2, or this. Okay, taking derivative for this equation x, this is the equation that we can solve the maximum condition of x. So derivative of x we can write like this: the x y equals 0, so 2 1/2, okay, 1/2 1 divided by y h minus y times y minus 2y equals 0. Oh, sorry. This is the h, and we can get y minus y is minus h, so y is h divided by 2. This is the value of y at maximum of distance. We can get that distance of x, so we can get x max equals 2 times square root of y times h minus y, and we can substitute y by this term, and x max equals 2 times h divided by 2, h minus h divided by 2, and 2 square root of this is term is equal h divided by 2, so this is h square divided by 4, and 2, we can simply this term like this 2, and we can get x max equals h, is equals h. So this is the maximum distance of this condition. Okay, like that. Okay, we move to the third question. A ball is thrown horizontally to the right from the top of vertical cliff of height h. A wind blows horizontally to the left, and assume simplistically that the effect of the wind is to provide a constant force to the left, equal in magnitude to the weight of the ball. How fast should the ball be thrown so that it lands at the foot of the cliff? Okay. This problem we can solve by some parabolic models or projective models path, and you can try this by yourself. Okay, you must write the equation of the parabolic or the projectile motion with the equation vy square equals vo square or vy square minus 2 times gh. That equation can solve this problem. Okay, let's move again to the third problem. Okay, first we can illustrate this condition like this. This is the cliff, a vertical cliff that have h of height, and the ball at this place that vo that have initial velocity vo. This velocity is horizontally motion. The horizontal position is given by equation of the projectile motion like this: x vo 1/2 gt square. This is not constant velocity because there is a wind that blow horizontally to the left like this. So there is acceleration or deceleration that have direction to the left, and the value of the acceleration is minus g, that explained by a wind blows horizontally to the left, and assume simplistically that the effect of the wind is to provide a constant force to the left equal in magnitude to the weight of the ball. So the weight of the ball is mg, so the acceleration of the winds also g, and so that we get the equation like this. Okay, when x as a function of t, that t equals 0, so the x is 0, and we can write x like this: vot minus 2/2 gt square equals 0. So 1/2 gt square equals vot, and we can remove t, and we get t equals 2 times vo divided by g. Time to hit the ground is given by right equation of the vertical motion like this. H equals Voy t plus 1/2 gt square, and Voy is 0. The velocity is horizontally moved, so Voy is the velocity in downward motion, of course has a value 0. So h equals 1/2 gt square, and we get t equals 2h divided by g. Okay, this value of t must be same so that the ball have a path like this, so the ball can hit the foot of the cliff at the end. So we can write t equals t, that the first t is 2 times Vo divided by g, 2 times Vo divided by g equals, the second t is square root of 2 2h divided by g, and we can get some quadratic of this term. All of this term for Vo square divided by g square equals 2h divided by g, and we can simply this term, and we get 2 times Vo square divided by g equals h. So Vo equals gh divided by 2. Okay, this is the velocity that should be thrown so that it lands at the foot of the cliff. Okay, like this. And now we move to the fourth question or problem. A ball is thrown eastward across level ground. A wind blows horizontally to the east. And assume, simplistically again, that the effect of the wind is to provide a constant force to the east, equal in magnitude to the weight of the ball. At what angle theta should the ball be thrown so that it travels the maximum horizontal distance? We can solve this problem by something that similar to the third problem. The equation and the value or the illustration. We can illustrate the ball that is thrown eastward like this, that have theta of an angle and Vo as initial velocity, and we can separate a vector of Vo as a vertical motion Voy and horizontal motion Vox. So there are two directions. Okay, this is the illustration of the problem. And a wind blows horizontally to the east, so a wind accelerates the ball to the east. That is the illustration of the problem. So first we can write the equation of vertical motion of this projectile motion like this. Y equals Voy t minus 1/2 gt square. This is the height of the ball at the top, so this is the maximum height of the ball. Okay, let's assume that this is the height of the ball, and we can substitute this term by 0 if we want to get times that the ball hits the ground like this. Okay, this is the time that the ball in the air. So we get 0 equals Voy t minus 1/2 gt square, and we get Voy t equals 1/2 gt square, and we can erase this and simply this term, and we get t equals 2 Voy divided by g, and Voy we can substitute by Vo sine theta divided by g. This is the usual time of the ball in the air. This is analysis of vertical motion. We can write it in this position. Vertical motion. And we can get the horizontal distance x Vox times t plus 1/2 gt square. G is acceleration that yields from the wind blow, so don't be confused that As usual, the horizontal distance has a constant velocity, but this term or this condition by the problem, we can get some acceleration g that yields from the wind blows. We can substitute t by this equation, and we get x equals Vox times t, equals times 2 Vo sine theta divided by g plus 1/2 g 2 times Vo sine theta divided by g square, and we can multiply this term 2 Vo square sine theta cos theta divided by g plus 2, this term is square, and we can get 2 Vo square sine square theta divided by g, and we can factorize this term, and we get 2 Vo square divided by g from this factor. Okay, so the else of factor is sine theta cos theta plus sine square theta. Okay, this is the equation of x, or x as function of theta. So what is the maximum horizontal distance? Okay, we can get it by the derivative of the function. We know that the maximum of distance of or dx is get by dx d theta equals 0. This is the term or the equation of derivative that can yield the maximum of horizontal distance. So the derivative of x is 2 times Vo squared divided by g. This is a constant value, so we can write it in the outside of the derivative process. 2 Vo squared divided by g times 2 cos the term of this. It can be substituted by sine 2 times theta times 1/2. Okay, and we can derive this term, and we get this term divided by 2. Okay, of course, and this term we can get the derivative term like this, 2 sine theta cos theta. Okay, of course this is equals to 0, so we can eliminate this term, and we can write it as a sine 2 times theta, and we can get the equation cos 2 theta equals minus sine 2 theta, and we can get sine 2 theta divided by cos 2 theta equals minus 1. So this is the tan theta by the identity of trigonometry. Tan 2 theta equals minus 1, and 2 theta is arcus of tan minus 1. We get 3/4 p, and theta is 3/8 p. This is the angle that can yield the maximum of horizontal distance. We can get the maximum distance by substitute this equation of or this function by theta 3/8 p to this term or this term or this term, like that. Okay, and now we move to the 5th question or problem. Okay, at t equals 0 on the planet gravitas increases, a projectile is fired with speed Vo at an angle theta. above the horizontal. This planet is a strange one in that acceleration due to gravity increases linearly with time, starting with a value of 0 when the projectile is fired. In the other word, g as a function of t equals beta times t, where beta is a given constant, and what horizontal distance does the projectile travel, and what should theta be to maximize this distance. Okay, we can solve this problem by some integral or derivative process. Okay, first we can analyze the height by function of t. G as a function of t equals y double dot equals minus beta times t. Okay, this is the acceleration. So the velocity y dot equals v as a function of t equals vo sine theta minus 1/2 beta t square. This is the equation of projectile motion that have the acceleration pt, that p is a given constant, and we can get the height y equals integral vt. Okay, we can integrate this term vo sine theta minus 1/2 beta t square dt, and we get, okay, write it as a function y as a function of t, vo sine theta times t minus 1/2 beta times t cube divided by 3 plus y t at the initial position. Give an identity of this term by 0 index. Okay, and where we have used the initial value of y and y dot. So this is the first condition, that this is a 0 and this is a 0 at the first or the initial value. So we can write it as a vo sine theta times t minus 1/2 beta t cube divided by 3 equals 0. Okay, we can get 1/6 times beta t cube equals vo sine theta times t, and t2 we can simply this equation, and we get t square equals vo times t, of course, sine theta divided by beta. So t equals square root of 6 vo sine theta divided by beta. Okay, we get times t like this. So therefore the final x value is x vo cos theta times t. Of course this is a constant velocity, so there is no acceleration on this equation, and we get x equals vo cos theta times square root of 6 vo sine theta divided by beta. Okay, maximum value of x we get from dx d theta equals 0. Let cos theta as a u and let this term as a v. Okay, so the derivative of this equation or this term is du d theta times v plus u dv d theta equals 0. You can substitute this term, so we get minus sine theta. This equation we can accumulate or compile this term to this term, and we can get square root of sine theta as a v. So we can simply this term of v by this. Okay, and u is cos theta, dv d theta is 1/2 1 divided by square root of sin theta times cos theta equals 0. Simply form from this equation, sin theta plus cos theta times cos theta is cos square theta divided by 2 square root of sin theta equals 0. Okay, we can write cos theta square, of course, divided by 2 square root of sin theta equals sin square theta. Oh, sorry, sin theta square root of sin theta. Okay, it's right. So we can simply this equation. We can move sin theta in left side to the right side, and we get cos square theta divided by 2 equals sin square theta, and we can get sin square theta divided by cos square theta equals 1/2, and we can change this term by identity of trigonometry. Is it can be tan square theta equals 1/2. So tan theta equals square root of 1/2, and we can take the plus or positive term. So theta is arc cos tan square root of 1/2, and we can calculate this by or compute this. So theta equals 35.3. Okay, this is a angle that can yield the maximum distance, like that. So now we move to the now we move to the sixth problem or question. Newton is tired of apple falling on his head, so he decided to throw a rock at one of the larger and more formidable looking apples positioned directly above his favorite sitting spot. Forgetting all about his work on gravitation, he aims the rock directly at the apple. Let's see figure. This. The apple falls from the tree just as he released the rock. Show by calculating the rock's height when it reaches the horizontal position of the apple that the rock hits the apple. Okay, let's make solution for this question. Let the initial speed and angle be VO and theta, and let the horizontal distance to the apple be L. Then the time for the rock to reach the horizontal position of the apple is, so we can illustrate this condition that VO have a direction like this, VO, okay, and we can separate the vector of VO in horizontal direction and vertical direction. That vertical direction have VOY and horizontal direction VOX. Okay, so we can write T equals L VOX. This is the L and this is the height. Okay, so the horizontal motion have constant velocity, so we can get time on this motion is L divided by VOX, and VOX is VO cos theta, VO cos theta, that theta is angle of VO to the horizontal direction. So the rock's height at this time is Y VOY T minus 1/2 GT square, and we can substitute VOY is VO sin theta times, we can substitute T on this term, L divided by VO cos theta minus 1/2 G, we can substitute again, TL divided by VO cos theta square. Okay, and we can simply this equation. Okay, and we get tan of trigonometry, L tan theta minus 1/2 G L VO cos theta square. Okay, this is the height of the ball. Oh, sorry, the rock. Okay, but L tan theta is simply the initial height h. This is the simply initial height of the apple, because we are assuming that the rock was aimed at the apple. So the height of the rock at time t, L divided by VO cos theta, is y h minus 1/2 G L VO cos theta. Okay, so this is the height of the rock of the apple at this time, and the rock therefore hits the apple. Okay, like that. Now we move to the seventh problems or question. Two balls are fired from ground level, a distance d apart. The right one is fired vertically with speed v. Let's see a figure. You wish to simultaneously fire the left one at the appropriate velocity u so that it collides with the right ball when they reach their highest point. What should u be? Give the horizontal and vertical components. Given d, what should v be so that the speed u is minimum? Let's make solution for this problem. Okay, we can know that the vertical component of u, this is a vector quantity. Okay, the vertical component of u must be uy equals v. Okay, assuming like that, because the y motion of the ball are independent of whatever is going on in the x direction. Okay, the time it takes both balls to reach the top of their motion is, we can write by the equation of projectile, Vt equals Vo minus Gt. This is the upward motion, and we know that Vt is 0 at the top, so we can write it Vo, and we get T equals Vo divided by G, and we know that this is Vo on the vertical motion is the initial speed that have a value v, so we can write T as a v divided by G. Therefore u vector quantity, ux uy is of course the velocity is displacement divided by times. This displacement is d divided by t. Okay, and is v value of velocity of the vertical motion. So t is equal to v divided by g, so we get dg divided by v. Okay, this is the vector quantity of the u as two direction. Hence the value or quantity of this vector as a scalar quantity like this is square root of the dg v square plus v square. Okay, so this is the answer of the first question. What should u be? Give the horizontal and vertical component. This is the answers. And given d, what should v be so that the speed u is minimum? So we can taking the derivative process. Okay, by the derivative process, we get minimum value of v by, okay, we can write it like this, of course, equals 0. So this system has derivative form 1/2 1 divided by square root of dg divided by v square plus v square times dg square times minus 2 divided by v cube plus 2v. Okay. Oh, sorry. This is spirit. Okay, spiritive term equals 0, of course. And we can spirit this term. This term or this factor is equal 0. So we can write it like this. dg square minus 2 divided by v to the 3 plus 2v equals 0. So dg square minus 2 v to the 3 equals minus 2v. And we can simply this term or this equation like this, and we get dg square v to the 4, and we can know that v equals square root of dg. Okay, this is the v, so that the speed u is minimum. Okay, like that. And now we move to the 8th question. A plane tilts down at an angle theta below the horizontal. On this plane, a projectile is fired with speed v at an angle theta above. Sorry, I forgot to put the figure on this question, so we can illustrate the figure later. And what is the distance d along the plane that the projectile travels? What is d in the limit theta approach 90 degree? And what theta yields the maximum horizontal distance? Okay, we can illustrate the figure. Okay, there is a plane. Projectile is fired with the v of initial velocity, and theta is an angle above the horizontal, below the horizontal. Okay, theta. And the speed is theta to the horizontal, above the horizontal, so theta is below and the above the horizontal. Okay, this is the same value, and d is distance along a plane that the projectile travel. Okay, so the path of this projectile like this. Oh, sorry, it must be d. Okay, d. Okay, like this. Okay, let's make solution for this problem. The coordinates of projectile are, so we can write the function y as a function of t, sine theta, t, k, gt. Like this, the coordinates y and x is equals vo cos theta times t. This is the coordinates of the projectile, the value of x and y. And the projectile hits the plane when tan theta equals minus yx. Tan theta is yields by analyze the coordinates of y in horizontal coordinate, horizontal axis, sorry, and the horizontal axis x, and this is y. So this is a minus y and this is x. So the theta is minus y divided by x. This is the analysis of the projectile that hits the plane geometrically. So we can write y divided by x equals minus tan theta. Using the expressions of x and y and give VO sine theta minus 1/2 g t square and x is VO cos theta times t, of course, equals minus tan theta. And we can simply this on this term, we can simply so that tan theta and this term divided by this, we get 1/2 gt divided by VO cos theta equals minus tan theta. We can move this term to left side and we get 2 times tan theta equals 1/2 gt divided by VO cos theta. So t equals 4 tan theta VO cos theta divided by g. We know that tan theta by identity of trigonometry, tan theta times cos theta is sin theta. So we can write T as 4 tan 4 VO sin theta divided by g. This is the time of this condition, the times projectile in the air. So we can analyze the horizontal equation and we can substitute the value of t, cos theta times t. We can substitute t by the equation that we get from this analysis. Okay, x equals VO cos theta times v for VO cos sin theta divided by g. Okay, and we get from the identity of trigonometry 2 sin theta cos theta, 2 sin theta cos theta equals sin 2 times theta. So we can write it as 2 VO square sin 2 times theta divided by g. This is the horizontal distance. And okay, what is the maximum value of x? We can write dx d theta equals 0. So this is constant value. We can separate it and we get the derivative of sin 2 theta as 2 cos 2 theta equals 0. Of course, cos 2 times theta is equals cos 90 degree. It have a value 0. And we know that from this equation 2 theta is equals 90 degree and theta is equals 45 degree. And the distance along the plane is t. From geometrically we can write t as x cos theta like this. And we can substitute x by 2 VO square sin 2 theta divided by g and times cos theta. So we can get t equals 2 VO square. It can be changed by 2 sin theta cos theta divided by g cos theta. We can simply this term and we can get t equals 4 VO square sin theta divided by g. Okay, which approach this is value when theta equals 90. So d equals 4 VO square divided by g. Okay, and we have formulate the t in the limit of theta approach 90 degree. Okay, like that. Okay, we move to the last question, the 9th question. Okay, you throw a ball with speed VO at a vertical wall, a distance L away. At what angle should you throw the ball so that it hits the wall as high as possible? Assume L less than VO square divided by G. And why? Okay, let's make solution for this question. The maximum range of the projectile is VO square divided by G. Okay, the maximum. So we need L less than VO square divided by G. If the ball is to reach the wall, the time to the wall is x equals VOX t. And L, the distance L away, equals VO. We can substitute VOX by VO cos theta times t. So we can get t equals L divided by VO cos theta. We save it. We can write the vertical motion y equals VOY t minus 1/2 gt square. And we can substitute VOY by VO sine theta times t minus 1/2 gt square. Plugging in our two give t, we can substitute by this, plugging it, and we get y equals VO sine theta times L VO cos theta minus 1/2 g times L VO cos theta square. Okay, and we can get simply form by reduce this term, and we can get tan theta from sin theta divided by cos theta, and we can write it as L tan theta minus 1/2 GL square, of course, VO square cos square theta, of course. And what the maximum of y? This is the condition that must be reached as high as possible. So we can taking derivative for this equation. So we can write dy d theta, because y is as a function of theta, equals, of course, 0. So the derivative form is tan theta being secant square, and second term we can write the constant value. We get minus 2 cos to the 3 theta minus sin theta. This is the multiplication process. Okay, and we can simply this term GL square VO square 2 times sin theta divided by cos to the 3 theta equals 0. We can move this term to the right side, and we get secant square is 1 divided by cos square theta equals this term to the right side, GL square VO square 2 sin theta divided by cos to the 3 theta equals 0. And we can simply this equation, sorry, this is not equal 0, because this is equation that this term have moved to the right side. Okay, we can simply this cos and sine divided by cos is equals tan. Okay, and L is equals 1. This is equals again, and 1 is tan theta GL divided by VO square, of course, and we can get tan theta equals VO square divided by GL. Note that the L less than VO square divided by G condition implies that theta more than or theta is bigger than 45 degree. So tan theta less than VO square GL, and tan theta is 1. This is the minimum value of tan theta on this condition, of course. So VO square GL, and we get L less than VO square divided by G. This is the value of L, and we have value of L like that. So this is the end of this video. More or less like that, the use of the projectile motion analysis by the equation or function to solve problem related to parabolic path or projectile motion, of course. And we can develop and apply it to other cases. Thank you for your attention. Please, you can comment below if my delivery is not appropriate. Thank you again. See you soon. Untuk kawanku.